Hi class. So I want to give you guys a quick, well I don't know how quick it'll be, but a short summary of Chapter 7 to help you review for the test on the Chapter 7 material. Now I'm sorry, my document camera is having a hard time autofocusing. So right now I've got it focused with my hands still, but even there it wants to go in and out. So I'm sorry about that. Well, hopefully it'll stay focused enough for you to be able to to follow along with me. So first thing, Chapter 7 got two big themes, exponents and polynomials. Now in this first section, I'm just going to cover exponents. And I mentioned that you can have a 3x5 card on the final exam. And I don't know how comfortable you are with the exponent laws, but those exponent laws might be helpful for you. If you haven't nailed them down, you could put those on your 3x5 cards. So let's start with the exponent laws to begin. There's several of them. One of them says if you have a base times a base, or just a quick reminder, the base and the power, this is called the base, and of course that's called the exponent. Now, for the laws to work, you have to have the same exponent base, x's times x's. And we discovered a shortcut that you can add the exponents to make a simplified answer. So this is our first law. And it could look like 5 to the 7 times 5 squared, which equals 5 to the 9 power. So we can use this law to simplify the multiplies of all those 5s with 7 plus 2. Now notice it doesn't say 25 here, because I'm not doing just 5 times 5 and getting 25. I've got 5 times 5 times 5 times 5 times 5. There's 7 of these times 2 more of these. So I'm multiplying 9 factors of 5. So notice here, x's to the n power, x's to the n power. Stay x's, but the power now is n plus n. It could be w cubed times w to the 11, which equals w to the 14. Okay, now there is a similar law with division. X's to the m over x's to the n equals x's to the m minus n. So if we had, instead we had w to the 11 divided by w cubed, that would be w to the 11 minus 3, which equals w to the 8th power. So there's the simplified version of that fraction. There's a couple more, there's several more laws actually. If we have a base A times a base B with a power on it, well, this law says, hey, everything in here is being repeatedly multiplied. So we've got AB times AB times AB times AB. When it's all done, we're going to have A multiplied by m factors of A, and we're going to have B multiplied together with m factors of B. So the exponent applies to everything in the parentheses. So if we had 2wy raised to the 4th power, that would be 2 to the 4th power, w to the 4th power, y to the 4th power. Notice how the 4th power applied to every factor inside. Another law. If you have a power, and that power is raised to another power. So it's a little different than number 1. Number 1 has an x factor with a power and an x factor with a different power. This is only one x factor, but the power on the x factor is raised to another power. And that has a shortcut law that we learned where we multiply the powers. So if we did 5 to the 7th, raise that to the 2nd power, that would equal 5 to the 14th power, because a power on a power, we multiply the powers. If it was w to the 11th raised to the 3rd, well, a power with a power on it, we multiply those powers and we get w to the 33 power. Okay, actually I should have written this next one right after number 3. Number 3, multiplying your bases with one power applies to both. So this number 5 law is a division law, very close to number 3. They're like cousins. Here I have a division inside. I'm taking A as a base divided by B as a base and everything as an M power. Well, that just means all the A factors will be repeatedly multiplied M factors of A, and all the B factors will be multiplied M factors of B, and we get this fraction. So it's very similar to number 3, the M power applied to everything inside. It applied to the top and to the bottom. All right. Got a couple more laws here for you. Let's see, number 6. This one's kind of an easy law. If you have a base with a 0 power, what does a 0 power do to your terms? Or your factors, I mean. X to the 0 power equals 1. So, if we have W to the 0 power, it equals 1. Example, if we have 9 to the 0 power, it equals 1. If we have 9 to the 6th power, W to the 11 power divided by pi to the 7 power, and then we raise that whole group to the 0 power. What does that equal? It equals 1. So, except for if W is 0. 0 to the 0 power is a little weird. So if X is 0, 0 to the 0 power would be a weird thing. That's the only case when it doesn't work. But this, in general, we say everything to 0 power equals 1. Basic one, number 7, also a basic one, and that is X to the 1 power. Well, X to the 1 power equals X. So if you just have a variable, it's understood that there's a 1 power on it because anything to the 1 power is itself. And then we have one last one, 8. X to the n power, X to the negative n power. And that makes a reciprocal. You flip the X, you make a reciprocal of your base, and when you do, the negative power makes the reciprocal, and then the n part on the power stays on the X. But there's been a reciprocal, so a negative power makes the reciprocal, and then the X has now got a positive in power when it's on the bottom. Now this law has a few counterparts, a few cousins related to it. If we have two bases, A over B to the negative n power, the negative is going to make the reciprocal. So notice how I flip the fraction. So the negative part of the exponent creates a reciprocal, just like here the x's went on the bottom. Well, here the a's went on the bottom and the b's went on the top. And there it still has a power, but now the power is n. So one more cousin to this thing here. I'll change colors so you can kind of see it a little better. It's related to all these negative powers. Now I'm going to make one that's more complicated. Let's say we have a to the negative m. So this time it's m, not n. And c to the positive w. We're assuming these are positive exponents, negative exponent, over b to the negative n. So all of them have different exponents. M's, W's, and N's. Now we've learned that a negative power makes a reciprocal. Now A has a negative power on it, so A is going to be a reciprocated. Now it's on the top. Well, if you take a reciprocal of something on the top, it's going to go on the bottom. So these A's go down on the bottom, and now the power of A is a positive power. Okay, now what about B's, the factors of B's? B's have a negative power as well. But a negative power makes this reciprocal. So before X didn't really have a top and bottom, but any whole number thing, you can put a 1 under it, so you can kind of think of x being on the top and it went to the bottom. But here b is in the denominator, it's already on the bottom. But b also has a negative power while it's on the bottom. Well, a negative power makes a reciprocal. So if something is on the bottom or in the denominator and you reciprocate it, it winds up going to the top. Okay, now what about c's? Does c go on the bottom or the top? Well, it turns out c is going to stay on the top. How come? I thought we were supposed to flip everything. Well, no, we don't flip everything. The negative power makes a reciprocal. So a had a negative power, it went to the bottom. B had a negative power, it went to the top. But c has a positive power. It does not get the reciprocation. It stays where it was. So notice the only things that changed were a and b, because a and b had the negative powers. C didn't move. It had the positive power on it. Okay, so there's 8 laws here. These are all 3 related. They're, more complicated versions of number 8, but they're all variations on this number 8 law. Now, what we need to do is we just need to practice some simplification. So that's the big skill that I want you to be able to do, is use all these laws to simplify expressions. And let's practice with some problems of simplification.